So the first one, with or without a hat, the or, some of you subtracted, so just make sure when it's or, it's adding. So you were so close, like you actually realized, okay, this is two different cases, but you subtracted, so make sure you add. Next, we had a combination scenario. When it's combinations, when there's no specific requirement, you want to consider all 22 players and just choose 5, right? That's it. 22, choose 5. Even if the 22 had not been explicitly stated, you would have wanted to add up your 22 and just go, I don't care in which, what kind of arrangement the teams are in. Just 22, choose 5, okay? Now it says must be 2 defenders, so we want exactly 2. So now we want to separate the subgroups. So from the 8, I choose 2. And from the 14 that remain, I choose the remaining 3. I need a team of 5, remember that. It's times, not add. Next is the at least one forward. So you want to go total minus forward. That's what you want to do. You want to take away all the teams that have no forwards in them. So from the 14, you choose absolutely none. So some of you don't have the 14, choose 0. That is fine. But remember that it's there, right? 8, choose 5, subtract, there we go. Next, Shifley needs to be on there. That's the 1, choose 1. You don't have to have the 1, choose 1 there. But as long as you have the 21, choose 4. Because remember, if 1 is out, that player must be in. So now you have 21 left. And you need to choose 4 more to get your team of 5. Okay, so that's what you get there. Next, you have to have your restrictions to get full marks. This one ended up being a linear. So it's just n is equal to 41. That's all that was required there. So no quadratic formula on that one. I should have done a quadratic formula, but I wanted to focus a little bit more on the other because it takes time to do, right? Next, you know what? Overall, very well done. Yes, some of you had hiccups. Yes, some of you picked the wrong number. One little mistake anywhere and it all falls apart, but that doesn't, you don't lose the whole thing. I still honor the work that follows, so it's 525. Next, we had the passwords, right? So 52 because it's upper and lower case, so it's 26 and 26. 10 digits, 4 special characters, so we've got 66 numbers. So no restrictions, it's 66 to the power of 5, okay? Because you can use all 66 in every slot, every one of those 5 slots. Repetition is allowed, but they can't have all characters the same, so you can't have these types of passwords. Since you've got 66 characters, there are 26 passwords that would all be the same, right? All exclamation marks, all question marks, all A's, B's, C's, upper, lowercase, all of the 66 of them you want to take away from the previous answer. That's why you get that. Next, must start with an RWZ. I know I messed with you a little bit, but remember, they're all different. Like these are 3 different cases, whether it's capital, lowercase, it doesn't matter. So there are 3 cases, and you can't have repeats. So most of you did this kind of work. So it's 33, and then we're down to 65, 64, 63, 62. Okay? Remember, 1 slot takes away 1 number per case. So it's not 66 minus 3 is 63, right? Some of you went 63, 62, and so forth. That's dangerous, so watch out. At least 1 repeated character. Then you take your total minus 66, pick 5. You take away all the ones that have 1 or more repetition. You take away all the ones that have no repeats. And then you're left with this. I wanted to maybe explain this one more time. Some of you were trying interesting things, right? So some of you were saying 66 to the 5 minus, you did the 66, 66, and then you went down 65, 64, 63, something like that. So what you're telling me is this is one of the cases where these two are repeated. But there's still cases where the first one and the third one are repeated, or all three of them are repeated, or you know what I mean? So if you do it this way, that's not going to work for you. You're only subtracting a scenario. You're not subtracting all of the possible cases, right? So don't do it that way. If it's at least one repeated character or have repeated characters, use this approach, okay? Packages for activities. This one was the OR was supposed to give away that it's a plus situation, and the activities, the order doesn't really matter, right? If you've got that package, the idea was the packages was, I was hoping that that was going to give it away. A package, you don't really care the arrangement. We're not lining up to take pictures. We don't have specific positions, nothing like that, okay? So 330 there. There was your word. You know what? I think all of you nailed that one. So I hope that that one is very classic. This is a classic. Easy 2 marks on an exam if you see this. Then you were supposed to do a tree diagram there. I think some of you need to improve a little bit. I know I didn't spend a whole lot of time ACing you on it. But basically, if you do a tree diagram, you start with the first coin. This is supposed to represent how many outcomes if 2 coins had been tossed. There's 4, but you needed to go one step further where the 4 branches branch off again, okay? So you should have 8 little endings here, 8 roots. And why is that? Because 2 times 2 times 2, 3 coins, sorry, that's 8. If you multiply that, you have 8 outcomes, so you should have 8 here. So if you follow this, this is a teachable moment here. If you missed the boat here, I was a little generous. If you had something decent there, you got 1 mark. But this is important. It's the next part. So this, if you follow this branch up here, that's heads, heads, heads. Like all 3 coins landing on heads, right? Then you've got heads, heads, tails. That's your second outcome. So I wanted you to list all of the possible outcomes. This is going to make your life easier for this part because it said, how many ways can you have at least 1 landing on tails? At least 1. So 1 or more, that's what that is saying. And so it's these 7 outcomes here. 7 of the outcomes have at least 1 tail. This one has no tails, right? So that's why we have 7 out of the 8 contain at least 1 tail. Next, the birthday, putting people in cars. You're taking your total, you're putting them in other cars. So this was supposed to be a multiplication scenario. 27,720. Next, we've got two friends right beside each other. So 2 factorial is the group, and then remember that is now 1 slot. So you count that 1, 2, 3 all the way to 11. So it's 2 factorial times 11 factorial. Okay, that's how you do that. Then simplifying, you break up the top. There's only 1 factorial. There shouldn't be any more factorials anywhere in here. You're breaking it down up to this point, then you cancel with the denominator. It ends up being 150 pick 4, which is 486 million and something. Next page. I'm not showing a whole lot of work for this one. At least 1 question right. The marks here kind of should tell you there's more than meets the eye. So why 4 to the 10? Because there are 4 options, right? 4 for every question. So 4 to the 10 is all possible. This is all minus all wrong. Because every single question has 3 wrong answers. If there's 4 options, 3 will be wrong. So you're taking all possibilities minus getting them all wrong, okay? So that leaves you with this many ways to answer where you get at least one of them right. Maybe the first one and the second one, and so forth. Okay. All right, next. This one was supposed to be, because of the word arranged, I would say that is very much a dead giveaway that this is permutation. It's not combination. So that's where you have either 12 pick 5 or you just put you do fundamental counting principle. Either one is fine. I was actually also happy with this one. All the same genres have to stay together. So you've got the 4 factorial, the 5, the 3, but remember you're still zooming out. It's almost like you have 3 tiles that you can move around. So that's where that 3 factorial at the end comes in. That's the zoom out part. So 4, 5, 3, just like your groups, like your subgroups, and then 3 factorial at the end to get the full marks. And this one, I'm going to highlight the word that I was looking for, or the main reference I wanted you to make is, for Francine, the order does not matter. But for Mandy, the order of the toppings do matter. The way they have been placed on the pizza matters. That's why one did at 16C3 and the other one 16P3, pick. So it's the order that I wanted to see there, whether order matters or not. So make a note somewhere. Talk about order, the order, whether or not it's relevant or irrelevant. Does it matter? Does it not matter? That's what I wanted to see there. So if you had something going on there, I gave you half. Next one is how many emojis can you make if you have to use at least one option? Question 1, this was how many subsets can you create? It was 26 if you add them all up. And then B was a TVM solver. So basically what you had to do is, if you switch your payments to bi-weekly, it's about half of your $300 payment. That's what I wanted you to kind of take from that. What happens if you switch to bi-weekly? So you had to change this to 26, negative 150, and it's 15,000 because you're getting the loan from the bank. It's positive. You solve for N. I turned the N, I divided it by my PY to get the years, and I multiply it by 12 to get my months. So it actually takes you only 53 months versus 60 months. Then you subtract the 2 to get your final 6.15 months sooner. So you save 6 months worth of payments if you do bi-weekly. So if you're at some point, you might sign for a mortgage, okay? You might take a loan out, and they might say it's $2,000 a month. If you take half of that, so $1,000 every 2 weeks, you're not going to feel it a whole lot on your page, like month to month. You're not going to feel it a whole lot, but it's going to shave off 3 years, 4 years on your mortgage. You're going to pay it off faster, okay? So the higher PY is, the better, okay? You're going to pay it off faster and save interest. All right.